Hello folks there, so it's Monday, or for some of you, and for Tuesday for others of you, and today it's our mechanics lesson, so it's all going to be about F equals MA, forces questions, specifically involving pulleys. So I'm just going to show you one question. I'm going to give you two from Maths Genie resources to have a practice at, but if you want to look in your textbook or in your revision guide and do a few more on pulleys, that's all a good idea. Let me know how you get on, upload some of the work that you've done, and we'll take it from there. Here's today's problem. So take your time, make a sketch of it, pause the video, see how far you can get, and then see how what you do compares with me. Now, I'm not going to lie to you, I dropped out of my physics A level halfway through, and so I haven't done that many of these in the last decade. There's more than one way. Whenever Suvat gets involved, there's more than one way we can do these things, and you may well find that the way you get to it may be more elegant, by which I mean generally simpler than what I do. But anyway, whatever happens, what I'm going to do works. Let me know if you think you found a better way. We're looking to find the time between the instant the particles are released from rest and the time when Q hits the ground. Now, you may well be asked about some of the assumptions you've made. So assumptions we've made, because it's a smooth pulley, is that there's no friction there. Also, this distance here, 4 meters and 9 meters, before Q hits the ground, we're going to get to a point where this pulley has to go over here, and we're going to have to make the assumption that that pulley doesn't interfere with things at all. What that also means is we're going to have to be working out two different periods of time. We're going to have the time until whilst this pulley is being dragged along here by it, and then we're going to have the time of free fall that happens afterwards. Okay, so let's do it one little bit at a time. To start off with, the tension in the rope here and here is going to be the same, and our way in is to make is to use F equals MA to make two equations so that we can simultaneously do it to find out what the acceleration is. You can find out what the tension is if you like, but in this question there's no need to find out the tension. In other questions there may be, in which case that's simple enough to do. So first of all, looking at for P, we can say that the force is all the force pulling it, all of it is going to be the tension, isn't it? And that's going to be equal to 8 as the mass times the acceleration. And good idea to put on here that we've got 8g going down there, haven't we? And we've got 10g going down there. Next up, if we're thinking about this particle here, what we've got is the force going down of 10g minus the tension in the string is going to be equal to the residual force that's pulling the particle down towards the ground. So that's going to be mass times acceleration, isn't it? So the mass being 10 and A. And we want to find what A is. So all I'm going to do is say, I know that T is equal to 8A according to that. So I'm going to substitute 8A, substitute T equals 8A into this equation, and that's going to give me 10g take 8a equals 10a. Now if I add 8a to both sides, that gives me 18a, and g is 9.8, isn't it? So I could change that now to 98. Therefore a is going to be 98 over 18, which is 49 over 9, or 5 and 4 ninths, isn't it? Or 5.4 recurring. But I'm going to use 49 ninths from now on. So now that I know my acceleration, so acceleration, I'm going to write that is for the first 4 meters of travel. And I want to know the time until Q hits the ground. So I'm going to have 2 times of travel. Time 1 is going to be first 4 meters, and time 2 is going to be the final 5 meters until Q hits the ground. So if I look at S for here, for time 1, they're starting from rest, so S equals 0. What else do I know? Not S, U equals 0. I want the distance to be 4, so that is S, and I know my acceleration is 49 over 9. The other 2 things we have are V and T. I don't need to know V, so I'm not fussed about that, but this is the one that I want. So then you get your formula booklet out, or if you know all of your SUVAT things off your head really quickly, still probably a good idea to look at them just to make sure. We want a formula involving S, U, A and T, or anything that's not involving V basically. So I'm going to use from that S equals UT plus a half AT squared. We can fill in 4 for our S, U times the time. Well, we don't know what the time is, but if we're timesing it by 0, that'll be 0. So it's just going to equal a half times 49 over 9 T squared, whatever that is. So T squared is going to equal, or T is going to equal, because we can put this all in our calculator in one go, can't we? 4 over a half times 49 over 9. And if you pop all of that into your calculator, you should be given 6 root 2 over 7, which is 1.212 seconds to 4 decimal place. In fact, shall we go to, no, if we go to, yeah, that's 4 significant figures, but let's just stay safe and go 1.8 for that point. Anyway, so I blither on. So that's the end of the time 1 bit. Now for time 2, we have got our initial velocity. Oh, it's going to be our final velocity from here. We're going to need that because then we can do the same thing again. So let's work out our final velocity from time 1 next. Simplest way I could see to do that would be V equals U plus AT, because now we know the time. So that's going to equal 0 plus 49 over 9, and I'm going to multiply that in my calculator, not by the rounded thing, but just by 6 root 2 over 7. In fact, I've still got that in there, so I can just use my answer. Do that, and that gives me 14 root 2 over 3, which is 6.5996, and it keeps on going. It's all going to round up to 6.60 most of the time, I think, but anyway, so 6.5996, and on we go. Right, so now that we've done that, we can do the same idea again over here. So we've got our initial velocity being 6.5996. Oh, that's an extra 9. We've got our distance this time being 5. We want to know the time. the acceleration will have changed. We're in free fall now, aren't we? So what's going on with this one up here falling? Well, that should be falling at the same rate, shouldn't it? So that should be irrelevant. Everything falls at 9.8 meters per second, doesn't it? Which means, as we've got those three again, we can just use this again. So we can say 5 is going to be equal to 0 times, not 0 times t, to 6.599, 60, in fact, let's just say we're rounding it up to about 5 decimal places, still comes out as 6.6, 6.6 t plus a half times 9.8 is 4.9 t squared. And if I just rearrange that, I've got 4.9 t squared plus 6.6 t, take 5 equals to 0. Now you can use the quadratic formula there, or you can just whack it into the calculator using your polynomial solver. If you're not sure how to do that, contact me, because I'm pretty sure you can all do that now. So t would then give us 0.5406, I think it is, to 4 decimal places. It also gives you a negative number, but you don't need to worry about that one. So therefore total time is going to be a 1.212 plus 0.5406, and that gets us to 1.75 seconds to 3 significant figures. Now I hope that wasn't too painful. I'd love to see a really quicker solution if anyone thinks they can find one. Alright, so what I'd like you to do next is just questions 1 and 2 from the Maths Genie F equals MA revision worksheet. That's there. The solutions are there as well, so you can mark your own work. If you want to do any of the other questions on there, that won't be time wasted at all. But as far as today's concerned, we are just focusing on the pulleys. All right, folks, have a good day. See you next time.